Foundations of Amateur Radio. When you use your trusty multimeter to measure the resistance across a 50 ohm resistor, it shows 50 ohm. But when you use it across a piece of 50 ohm coax, you see either infinity or zero. Similarly, when you measure across a folded dipole, you see zero, not 300 ohm. Does this mean that a 50 ohm resistor is somehow different than a 50 ohm piece of coax? And why is the feed point impedance of a folded dipole 300 ohm when your multimeter clearly says it's zero? Does this mean that there are two types of ohm? Today I'm going to explain why this is and what's going on. Yesterday I started reading up on the subject, and every single explanation I came across went into deep juju with scary maths, using complex and imaginary numbers. I did a bit of that in my dark past, but none of that is needed to understand what's happening. As you know, there is such a thing as direct current, or DC. We use it with batteries and little power supplies, in simple circuits and all manner of day-to-day activities. There is another world that we as amateurs use, the world of alternating current, or AC. In household wiring we use 50 or 60 Hz, and different voltages depending on where on the globe we are. In radio terms we use it for our transmissions, on HF at several megahertz and beyond. These two different worlds, the DC and AC world, don't appear to have anything in common. Here's the kicker though. They are the same thing. Yep, DC and AC are the same thing. What? Yep, I'm not making this up. As you might recall, if you look at an AC voltage, it goes from plus to minus and back again. A 50 Hz alternating current does this swap 50 times per second. When you're rag chewing on 40 meters or 7 megahertz, it happens 7 million times a second, from plus to minus and back 7 million times. Clearly, there has to be some impact on this massive level of activity. Think of direct current as an alternating current with a frequency of 0 Hz. That is, over time, DC doesn't change. So, DC is a shortcut for saying AC at 0 Hz. If you understand that explanation, then some really cool stuff starts to happen. Before I get to the cool stuff, you might recall Ohm's law, commonly expressed as, given a current and a resistance, we can determine a voltage. Said in another way, the resistance of a circuit is related to the voltage and the current in the circuit. Now, in this simple form of Ohm's law, the voltage doesn't change from plus to minus and back again. That is, over time there is no change. Now, if you start doing funky stuff with your voltage, like change it from plus to minus and back again, an additional type of resistance comes into play, called reactance. This reactance is the part that is affected by voltage change over time. So if you swap the voltage from plus to minus and back again 1,000,000 times a second, the reactance has a big part to play. In short, there are two types of resistance, one that is independent of time, called resistance, and one that is dependent on time, called reactance. Both of these, resistance and reactance, happen within a circuit. If the voltage doesn't change over time, then the reactance part is zero. And similarly, there are circumstances where you can have a resistance of zero, but have a reactance that's not. One example is a folded dipole. Now, if you combine the resistance and reactance, you get something called impedance. Now you have all the bits. Resistance is expressed in ohm, impedance is expressed in ohm, and thus reactance is also expressed in ohm. If we look at our folded dipole with a feed point impedance of 300 ohm, you now know that this 300 ohm comes from a resistance of 0 ohm and a reactance of 300 ohm at the resonant frequency, which is why your trusty multimeter shows it at 0, since the voltage it uses to measure is alternating at 0 Hz, which is not the resonant frequency of this antenna. Before I go, the rabbit hole goes deeper. Reactance itself is made up of capacitance and inductance, which each deal with the reactance in a capacitor and an inductor, but I'll leave that for another day. So next time someone tells you that the feed point impedance of your folded dipole is 300 ohm, you'll now understand why your multimeter says it's 0. I'm Onno, Victor Kilo 6, Foxtrot Lima Alpha Bravo.